Hey there, this is Lana. I'm going to make this video for 6.2 MyMathLab homework. I think it's 6.2, hold that thought. There it is, number 6. All right, now I'm not going to do the real one. The real one, of course, changes for everybody. I'm going to do an example from the view and example. And I'm not going to do any of what they're doing here. They're showing all this by hand stuff. We're not going to do that. Okay, so we're just going to work it with Excel because it's way better. Okay, so first thing they want to know is part A. I shouldn't have done it that way, sorry. Okay, so they want to compute the probability of X successes in n independent trials. And again, this is a binomial example. So it would be binom dist. Okay, now the number of successes, well, 4 successes is the most. Or you could, let me do it this way. I'm going to make this a different way. I'm going to make a table because I think it'll help clarify things. Now remember, you can have for anywhere from 0 up until whatever your n is. So since n for us is 14, we can have up to 14 successes. So you could have no successes, 1 success, 2 success, 3 successes, and so on. Okay, then I'm going to do it this way. Binomial distribution, and I'm going to let this x be the number of successes I want. I want 14 trials in this example. My probability of success in my example is 0.55. Now, of course, these numbers are going to change for every single example. Okay, and I'm going to choose false, but just because I think it's easier for you guys to follow along. All right. Oh, and hold on, if you didn't catch what I just did, I double clicked. Made so that my cursor isn't the handle, which is that bottom right corner where it turns into a plus sign. I double click and it fills in the whole column. Cool, huh? Fast. Okay, so now what they want to know is x is less than or equal to 14, or excuse me, x is less than or equal to 4, which is all of these ones, right? Because these are all the spots where it's less than or equal to 4. So if I want the answer to this, what I want is to add up all of these probabilities. Done. So 0.04262. Let's double check. Hold on, continue. They're calculating each one by hand. And look, there's the final answer, 0.0426. They have all of this work to do that. It's not even that hard. All right. So there are, of course, other ways to do this, tons of other ways. But I think this is honestly a very simple way to tackle binomial distribution problems because it shows you a visual representation of what's going on. You always have 0 up until n, whatever n is. You go over here and you fill in this formula, right, using those same x values you just found, the n that you given, the p that you're given, and always use false. And then there you go. Done, right? You just add up these 4 and you're done. All right, I hope that helps. See you later.